In this lesson, we're going to apply the concept that we learned about graphing quadratics into something that would actually happen in real life, okay? So a long time ago, physicists figured out that the motion of an object affected by gravity could be compared to its initial upward velocity by the formula, okay? So we're given this formula. Oops, sorry. Okay, so before we start, let's kind of try and label the parts. Well, we know that what we've seen before, h is kind of like the same as y. Okay, then we have a x squared plus b x plus c. Okay, so you can kind of see that x here is replaced by t and y is replaced by h. All right, so here's the first example problem. At a baseball game, a firework is sent straight up into the air with an initial velocity of 160 feet per second from a 10-foot high platform, okay? How long will it take for the firework to reach its maximum height? How far above the ground will that be? So let's kind of just draw a picture first about what this actually looks like, okay? So it's taken off of a 10-foot high platform. So here's a platform and it's 10 feet high, okay? We shoot off the firework. Okay, and then it comes back down. All right, so we want to know, well, how long time, right, will it take for the firework to reach its maximum height? And again, maximum height right here is the vertex. Okay, so time in our equation, t, is the x value. Okay, so x is going to be our time. And we know that x is the axis of symmetry. Okay, there's one other piece of information that I know. It started off from a 10-foot high platform. Okay, so if we think of this as a coordinate plane, okay, so we're starting out, this is 0 when y is at 10. So our y-intercept, which is c, is going to be replaced by 10. Okay? So I can now write our formula as h is equal to negative 16 t squared plus vt. I'm sorry. Let me erase this really quick. So this should not be, sorry, it says that the initial velocity is 160. So in for v, I'm going to put 160. Sorry, guys. So that should be 160t. And then the y-intercept plus 10. Okay? So now we want to find the t coordinate, okay, which is the line of symmetry, what you're used to as being x. Okay? So we know that the formula for that is negative b over 2a. Okay, so b here is 160, so negative 160 over 2 times a, which is negative 16. Okay, so then I have 160 over 32. Okay, they're both negative, which means they're both a negative divided by negative becomes positive, and here t is going to be equal to 5. Okay, so this is my axis of symmetry, which is 5. In order to get the vertex, I need to plug this back into my formula to get the h value. Okay, so plugging back into my formula for t, h is equal to negative 16. Okay, instead of t, I'm plugging in 5 squared, because t is 5, plus 160 times 5, plus 10. Okay, 5 squared is 25, so negative 16 times 25, plus 160 times 5 is 800, plus 10. Okay, so one more step, negative 400 plus 800 plus 10 is equal to 400 plus 10, so 410. So h is equal to 410. Okay, so this is our y value, which stands for the height. Okay, so our vertex is 410. Okay, so the last thing we want to do is scale and sketch the graph of the firework in h height over t time, okay? So remember that h is on our x-axis and t is on our x and h is on the y, okay? So in t time, I have 0, 1, 2, 3, 4, 5. Okay, so I need to count by an even number. So on the x-axis, I counted by ones. I'm going to label it time. And for height, okay, I see that I have to go all the way up to 410. So I think I'm going to count by 50s here. Okay, so 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. Okay, so my x value here is 5 and up to 410. All right, so here is my vertex. Okay, so in order to sketch the rest of the graph, I know that my a value here is negative 16, so it needs to be opening downward because it's a maximum, okay? Also, when time is 0, if I plugged in 0 to the equation, I would just have h is equal to 10. So I know that at 0, h has to be really small right here, and I can graph coming down, okay? So because we have our line of symmetry, both sides have to look the same, and here is my graph, okay? So if we want to really truly write what this means, what we just said that in 5 seconds, okay, because we're talking about feet per second, so in 5 seconds, the firework will be at 400 feet. Sorry, 410 feet. Okay. I also want to look back up at the problem and make sure we answered all of the questions. So it says, how long will it take for the firework to reach its maximum height? Okay, so it will take 5 seconds. And then how far off the ground will it be? It will be 410 feet off the ground. Okay? All right, let's check for understanding. Okay, so what I'd like you to do right now is pause the video for a moment and try this one on your own, and then we'll check back together. Okay, so here we have a baseball player throws a ball straight up into the air with an initial upward velocity of 48 feet per second. Okay, so we see that the velocity here is 48, already filled in for us. If the height h in feet after t seconds is given by the function, okay, so we want to find out these two answers. So we already have our equation filled in for us. Okay, we have the velocity filled in and we have the y-intercept filled in. So the first thing we need to do is figure out in how many seconds will t reach its maximum height. Okay, so t in this case would be like our x, what we want to solve for. So when we want to find the axis of symmetry here, we can use our formula of negative b over 2a. Okay? T is equal to negative 48, negative b, over 2 times a, 2 times negative 16. So here we have negative 48 now, over negative 32. Which is equal to 1.5. Okay, so t is equal to 1.5. Okay, so the time is 1.5 seconds. Let me draw a little picture of what this would be like. So a baseball player here is throwing a ball straight into the air with a velocity of 48 feet per second. Okay, we want to know the height, maximum height here, the height is after what amount of time it is. Okay, so that's why we're finding the vertex. So in order to get the vertex, we need to plug in t to our formula and solve for h. H is equal to negative 16 times t, which is 1.5 squared, plus 48 times 1.5 plus 4. Okay, so 1.5 squared is 2.25 times negative 16 plus 48 times 1.5, 72, plus 4. Okay? Negative 16 times 2.25 is negative 36, plus 72, plus 4, which is equal to 40. Okay? So h is equal to 40. So the height is at 40 feet. So I know that my vertex point here is 1.5, 40. Okay, so writing what this means in a sentence, it means that in 1.5 seconds, the ball will be at 40 feet. Okay, so again, I can label this point at 1.5, 40.